Here's a neat little 10 transistor radio that doesn't work. I'll bring it back to life in this video. Here's the 10 transistor solid state TRANSETTE radio receiver that I'm going to fix today. I'll take you through the entire troubleshooting procedure with me, step by step. I'll find the problems in this radio receiver and bring it back to life. I'll share that process with all of you. In order to get inside this thing, it's relatively easy. Just pop the back open like that, and we're inside, just like that. I'll zoom on in just a little bit here. So this is the bar antenna. This is where the reception happens right here, and this is the tuning capacitor up in the corner. So this is going to tune an oscillator in this section here. We can see IF transformers, so you can really see the process, how it's going to work. So the reception is here, the IF chain works up towards the volume control. We're going to have detection in here, and then it's going to run down this chain into the audio section and into the speaker here. So we have two really large transistors down here, which are going to drive this audio transformer, which is going to drive the speaker. So you can really see how this is working coming down here. There will be a little audio preamplifier in this section and all of that stuff. They all pretty much lay out the same. They put the parts in different areas and things like that, but you can usually follow the IF transformers. They usually work towards the volume control because the detection is going to be close to that. And then if this is the audio chain here, obviously it's going to have to run down here and out this way. And of course, other radio receivers are, relatively close to that. Again, just the layout moves around a little bit. So what I'll do is I'll put a battery in this thing. Got a brand new, fresh battery here. I'll put this on here, and let's take a listen. Oh, it is on already. A little bit of crackling there. Move that close to the mic. That's about it. Not much going on. Oh, a little bit of noise there. That might have been the volume control I was touching, but it's pretty much just silent. It's me lifting it up towards the mic here so you can hear that. A little bit of a scratchy volume control, but that's it. Pretty much nothing going on there. So the very first thing that I want to do is see if the oscillator's running. I'm going to start right at the antenna and work towards the speaker is what I'm going to do here. So I'll work my way this way and then down. That'll be my process. So I'll back this back out here, and I'll take a quick listen to this thing with the ultra probe. Now there's other ways you can do this. You don't need to use an ultra probe. I have a mesh under here just to keep things nice and quiet. So you can use a scope or whatever. This thing just makes life very easy, so I'll just use this. So turn this on. So the oscillator is running. That's the oscillator running. Not a whole lot of anything anywhere else. So that tells me that an oscillator is going inside here. So what I'll do is I'll grab a scope and let's see what that oscillator looks like and move forward with an oscilloscope here and basically just some basic tools like a DMM and all of that, and see what signals we can pick up and find out what's going missing and all of that great stuff. I'll get the scope and I'll be right back. All right, I've got my scope. So what I want to do is I want to attach the ground of my scope, or the common lead of my scope, to somewhere on here where I know which is ground. So what I'm going to do is just clip it to one of the cases of the IF transformers, because I know that's going to be ground. Hopefully that's going to stay on there. It is. And what I'll do is I'll go over here and just touch something that looks like it might be an oscillator. Nah, it's not so oscillating. It picked it up right in this area here. I'll go and touch this. Oh, look at that. That was a big signal. Touch that little screw on the corner of the tuning capacitor, and look at that. Wow, 15.9 volts peak to peak. So 1.2. So I'll move the tuning capacitor, and that should move around. So you should see this frequency move around here. And that's working just fine. So the oscillator is nice and clean. I mean, look at that sine wave. That's a really nice clean oscillator. But the radio is still silent. So what I need to do is get this out of the case and start probing around on the backside. So this is obviously going to be an IF amplifier down here, and this will most likely be another IF amplifier here, over here, and it'll work towards this detection transformer. So you can kind of tell the process. You have an IF transformer, you have an amplifier, you have an IF transformer, and we're going to have another amplifier right here, or this one could even be the amplifier, but I would think since this is further away, I would think that this is probably part of the audio chain instead. So you can really see the process here. It's the same thing as a vacuum tube radio. You have, the oscillator, which would be down in here, would be closest to the antenna, this little transistor down here. I'll zoom you in. So the oscillator would be, right here, and then IF and IF, or possibly IF, and then it would work up towards this way and then back down this way. So what I need to do is get this out so that, get this out of the way so that I can probe the backside of this circuit board here. So I'll take the battery off. And it's going to be held in by this screw here, and it looks to be that screw up there. So I'll grab a screwdriver off to the side here and remove these two screws, like so. Put that off to the side, or I'm sure to bump it and it'll go flying onto the floor and I'll never find it again. There we go. And that comes out relatively easy, just like that. And the circuit board can be laid right beside it. And now, here's a really good idea, and this should always be done. Take a picture of the board and make sure you get a picture of the wires where they're soldered, because what ends up happening is, because you're servicing this, you're looking at the parts on this side and looking where to probe and then putting it back and forth like this. A lot of the times doing this will snap these little wires off, and if you don't remember where the red and the black wire go and you break the wires off, that could be a real pain. So it's always a good idea to snap multiple angles of this, and even take a bunch of pictures of this side of the radio as well, the actual component side of the board. That way, if you pull a transistor out and you forget its orientation, you can zoom on into your picture and take a quick look and go, oh, okay, it fits in this way. So always a good idea. Smartphones are good for that, or if you have a small digital camera or something like that, it's very, very handy to have. Okay, so what I need to do is, this is obviously going to be ground. This is what holds the volume control in. This is going to be ground here. So what I'm going to do is I'm going to solder a loop onto this so that I can clip my test leads onto this area right here. So I'll grab a piece of scrap, whatever, an old component or something like that, something that I can just loop onto here. I thought I had one. I saw one. Oh, I got a piece of scrap wire right here laying on the floor. So I'll put this on here. So I'll add some solder to that. Just like this. Could probably use a resoldering anyways. Most of these aren't soldered very well. So I'll put a loop in here, I'll solder that in like that. Bend this around. The reason I'm forming a loop here is it makes a little bit better of an area to to grab to. That's all. Just like so. Just tack that in. Of course, that's all going to get removed in the end, right? So that's what's going on there. So you can see that okay. So now what I can do is clip my scope on there. You can get all of this into the scene here, hopefully. It needs to be on this angle, so it doesn't view very well. Put this all in here. Okay, so we saw that we had an oscillator signal right here. Pop the battery back onto this. Leave the volume at max, that's fine. So we saw that we had an oscillator signal right here. As you can see, it takes up the entire screen. So what I want to do, because I'm going to be looking for a very small signal, is I want to make sure that this is going to be AC coupled. Okay, so I'll hit A here and I'm going to go coupling to AC. So that way I'm going to be looking for small signals. What will happen is if I have any DC level, it'll lift the trace off the screen. By having it AC coupled, I don't have to worry about that. So now when I do this, it's going to, as you see here, going to show me that nice and easy, and I'll also be able to do that with, you know, signals that have a fair DC level behind it. All right. So what I'm going to do now is go to the back side. A lot of the times it may be beneficial as well to actually remove the little dial here. I think I'll do that just to get that out of the way. There's a lot of little solder connections on the bottom side here, so I might need to get under that. Be sure to put this off to the side with that screw where I bump it. It's just flying onto the floor and I'll lose that as well. All right. So now I'm touching the screw here. That's going to be soldered to this post right here. So that's the oscillator there. Now this is going to be the first IF transformer here. I can see 1, 2, 3 leads. Let's see if I can zoom you into that so you can see that a little bit easier. So you can see we have, this will be the oscillator here. I can see a little tab bent from the oscillator transformer there, or coil if you prefer. You can see that we have 3 little leads coming out here. This is where the case of the first transformer is bent over, and then we have 2 leads right here. So really, in order to see what's going on here, you know, I can probe here and move my way along. So I have this one here, and then we can also see the second one. This black wire is in the way here, but we can see that we also have what looks to be the 3 leads here, and then the core, and then the 2 leads, one here and one here. And then the next one is over here. So we can see the bent one here. We have the 3 leads here, and then the 2 up here. So you can kind of see the pattern of the way things are. And of course, they've been nice enough to put C and E for collector and emitter. This looks like base here. Of course, it's not everywhere, but it is there. So you can see, I'll move the focus up here so it doesn't do that. So I'll back this out so you can see the scope screen as well. Move this up to the scope screen here. Hopefully that makes things a little bit easier. It's out of the way. Okay, so I'll probe the IF transformer right here and see if I can find anything here. Looks like the scope is looking for something, and it did find something. So I do have signal at the transformer there. See if there's anything at the out here. Pretty low. So let's go to the collector of this first transistor here. And there is action there. So I'm at the collector of this first little transistor right here, this little one right here. So between the 2 IF transformers, How do I know it's the collector? Well, it says C right there. They made it nice and easy. The others may not be as easy. So probably have to go from side to side here. So another thing that would be very easy, you see I have signal here. That was at that collector. Now if I go to the other side of that transformer, it should be right here. So it looks like it's, you know, there is signal, some noise and stuff happening there. So I'm going to have a transistor here. The leads run this way. So I've got the three little, oh, I heard some static there. Do you hear that? That's interesting. Wow. That is, I am ever so lightly touching that. Let's see if I can demonstrate how light I'm touching that. Here is a Q-tip. And I pulled some of the fluff off the end there. I'm hardly even bending the cotton. That. There's something interesting happening right in here. I'm just touching that. So it's either the transistor here or maybe this looks to be a resistor over here is possibly an issue. I think it is this resistor. It's not, oh, or is it the cap? No, it's going to be this resistor here. All right, what I'll do is I will desolder this resistor here and see what happens. So I'll just get rid of the power, find out what's going on with that resistor there. I don't want to be poking my desoldering tool in here with any kind of power on it because I don't want to be shorting anything. Okay. It's always fun to locate these. So this is the one that I'm touching right here. So what I'll do is it looks like it's going to be in this area right here. So what I'll do is I will desolder. I think it's jumping these two right here. So what I'll do is I'll grab my desoldering tool and try to come in on an angle that will show you what's going on here. And I think it'll be, I don't want to burn this little wire here, so I might need to, pardon the, I'm going to be in the way here for a moment as I'm trying to desolder this. Oh, look at that. There's nothing even in that. That's interesting. Okay, we'll go over here. I think that would be the part. Oh yeah, it is. So it looks like the lead on the bottom is broken off. So maybe it was flexed one too many times, or maybe somebody else was in here at an earlier date poking around. These feel very flimsy. They're so soft, like abnormally soft. That almost feels like a solder leg. That is so soft. So what would the value of that be? I suppose I could read to the end there. Looks like it's, that center color looks odd, like it would be 480 or something like that. Closest value would be 470K to that, I would imagine. So what I'll do is I'll put this down here on the mat and I'll take a resistance reading. Let's see here what I got that will do that. Maybe I can plug some leads just into the top of this thing. Might be easier. All right, just plug some leads into this thing. All right. What have we got? Let me focus up here. Yeah, 470K. So 470K ohms. So yeah, it's yellow. So that should be purple in the center, but it doesn't really look too purple, does it? Looks like white or something. Maybe it's just worn off. But anyways, yellow, purple, yellow is 470K. So I'll go grab a 470K ohm resistor and put it in this board here, and we'll see what happens. All right, somewhat era-specific 470K ohm resistor. Bend that over like that. And maybe clip the leads just a little bit shorter to make things easier to get into the board. So I'll just cut some of the lead length off, like so. And on this side of the board here, let's see. They had this one like so, but it makes it very easy for this lead to touch the transformer shell. So I think I'll put this one in the other way. In like that. There, that way the resistor is up against the transformer shell, not the actual lead, so it can't bend over and actually touch that. That should be okay. Not dealing with any crazy high frequencies in here anyways. The IF in this is 455, something like that. So I'll leave that right there. And pardon the noise in the background there, some traffic in the morning here. And I'll solder this one right here. Just like so. All right. All right. Let's see what happens. Ah! All right, I'm trying to look for this here. So I can probably just turn it with my fingers. That's receiving. That's full volume, not very loud. Receives really well. Very low volume though. And it should be quite a bit louder than that. So there's a capacitor here and a capacitor here in the audio section. So this one is 2. Looks like 2 microfarad. You see that? 2 microfarad at 3 volts. And then there's another one down at the bottom here. You can see that there. LCOM. 30 microfarad at 10 volts, this one is. So chances are one of those is going to be affecting the gain. So what I'll do is I'll just grab a random cap here. What have I got laying around? Maybe I don't have any laying around. Well, here's 10. And I found a 10. So that's kind of nicely in the middle somewhere. So I'll cut that lead so that it's the same length here. See that? So I'll cut it the same length. Makes it easier to push this into circuit that way. So let's try this first one. What I'm going to do is just bridge this capacitor across this. A lot of the times these caps just go open over time. So that's the failure of a lot of these little transistor radio caps. So what I'll do is this side here, it looks like they've marked the positive sides of the caps. See that little positive with a stripe there, which is opposite to what these are because the stripe is negative on all these newer caps. So they've marked the positive side, a little plus there. So that will be this way. So that looks like it's running from here to here. And not much change there with that added in. So I'll go across this one here. So I think the positive on that one is probably going to be the same. It's me touching the oscillator here, changing the frequency. Yeah, that's the little plus right down at the bottom there. You see that? I can see that over here. So the plus is on that side. So the outskirts is negative, which would make sense because this is running up here to the negative side, right? So let's see what happens if we bridge that one. So that would be from here to here. We'll make some connection here. Oh, listen to that. So this capacitor is obviously low or open. So what I'll do is I'll get rid of this again. And we'll desolder this cap and see what happens here. Looks like they've bent the lead over. It's one of the things they love to do with these older radios. Just bend leads over everything. So when you try to remove everything, it lifts traces. It's wonderful. That one was straight up and down. All right. This will come out now. Oh, look at that. A cap with a wax bottom. It looks wax. Is it wax? No, it's an epoxy that looks like wax. I thought that was wax. Doesn't that look like wax? It's not. It's actually an epoxy that they put in the bottom there. So this should be 30. See, there's that little plus symbol. This should be 30 mics, 10 volts. So what I'll do is I'll back this out here. I'll grab the cap checker right here. And let's see, plus is this side. 2 nanofarad, 2.4 nano. That is pretty open. So that is pretty open compared to, just short that cap there, compared to this 10 mic cap. There it is, 10.4 mics. So I need to find a capacitor that's around 30 mics. Something on the bench, 30, 40, 50 would probably be just fine. It's just to establish gain in that stage. So 30, odd value, you know, would be 33 nowadays. So I'll go find something and I'll be right back. All right, I've got a 33 at 35 here. So 33 microfarad at 35 volts. So I'll put that into here. Like so. No need to bend the leads this time. Down here so you can see. Nice and straight. Sit on that. Focus a bit. All right. There. There. All right, this should be screaming loud now. Let's see, what do we got going on? Here it is. Oh yeah. That's very loud. Lots of stations in there. Thing is receiving very, very well. Imagine I could check the IF as I'm here. So what I'll do is I'll turn on my, take this off for a second. I'll turn on my RF signal generator. So what I want to do here first of all is, so I know the IF, the beginning of the IF is going to be right here, right? This is going to be ground, right? So you can see it coming around here, moving its way around, so almost like a ground or coupled to ground. Anyways, for the RF ground anyway. So this is going to be where I want to put a signal in. So 455, I believe, is what this is. In the bottom of the case, it said, had a bunch of info here. Yeah, you can see right here. So 455. Unfortunately, no schematic. And I couldn't find anything. I looked around for this, so it would have been fun to have a schematic and go over that, but unfortunately no schematic. So what I'll do is I will grab a capacitor here, something I can just tack into circuit. 0.001, 0.0047, that'll be just fine. So I will tack this into here. This is very much on the fly, so hopefully see here, this is all going to be okay. Put this in here like that. All right, so allow me to get a signal from my signal generator in there. So what I'll do is I'll grab some test leads, turn on my signal gen. So got lots of stuff over here. I'll move you over here for a second so you can see that. Let's see, where am I? Over here, there it is. What I'll do is I'll turn on the signal gen. The last time I used it, I think it was at 455. There it is, 455. So obviously I aligned an IF previous to this. I do remember the radio receiver I was using it on as well. So I will go to, say, to start this alignment off, I'll go to, say, I'll feed it with 5. Actually, I better go over here to amplitude. Let's try that. 500. You're supposed to be doing amplitude. Amplitude. 500 microvolts. Okay. And I don't really have a tone, but that's fine. I'll look at it with a scope instead. So I'll go down here. Again, and I will clip the, go back to scope. Might need to go A, and it's still AC coupled, which is a good thing. Okay. Put this on here. And put this on here. So now I'm feeding 455 into this thing, right at the beginning of the IF, and I will be probing the out. So this is the IF out. So this should be on the top of this transformer, one of the legs here. So I will grab something to twist this with. That should be okay. Put this back on and we'll see what I've got. Leave the volume down. Okay, so I'll go to the, go here for a second. Okay, so that's 500 microvolts in there, pretty low, probably not going to see that. So I'll go to the collector of the IF chain here, look at this. Okay, so we're going to have something here. There it is. Okay, so I'll hit manual so it doesn't hunt around so much. So I go from there. All right, so hold this here for a sec. And I'm going to get onto this side here and move this one around. If I go here, maybe I'll do this. Get a bit more gain. See that a little bit easier. And it's going down. And I can see why that's right at the end there. That's just maximum. So let's see what this one does. I definitely want to turn that up. So I'm just tuning for a max. All right, and I'll go to the last one here. Let's see. It's gonna most likely be this. Wow, look at the gain there. So that those stages are working pretty good. No problems there. Lots of IF gain there. A little bit of a peak there, not too much. Go back to the other one. Yeah, I'm gaining a little bit. Back to this one. That's pretty much peaked, and we'll go to this one. Yeah, that one's backed right out. You see it move down just a little bit. So no problem. And that is an IF alignment just that fast. All right, what I'll do is I'll desolder this and put this back inside the radio, put all the screws back in, and we'll take a listen to it. It went together very quickly. I'll put the battery in the radio here and put the back on. It says earpiece here, so that's the earpiece there. And just like that, it's together. Let's take a listen, see how well it receives.
We decided to move and we moved.
Lots of volume.
Like trust.com, this is, I don't just...
1030 News Radio.
Noon. Now I'm there. I'm at the Marriott.
so many stations. Really good receiver. And that's the end of the dial. So we're back down here.
Of the open door, but I made the decision.
You know, breaking off and walking away on their own. Reminded us all, you don't have to be heartless. You've likely heard by now that the state of Texas is seeking to track down and arrest lawmakers who left the
Wow.
state.
Very loud. Very sensitive receiver. Works incredibly well for just replacing 2 parts. Now, in order to do a complete restoration on this, all these capacitors, these electrolytics, could be changed, and the IF is pretty much tuned at this point. You know, dial accuracy could be checked and things like that, but other than that, you know, the performance really isn't going to increase all that incredibly much. And at this point, these electrolytics are working, so you know, it's working very, very well. So I don't think the performance would get much better than that. It really is receiving quite well. So all in all, project successful. I'm very, very happy with that. If you enjoyed this video, definitely subscribe and hang around. I'll have many more great videos just like this coming in the very near future. Lots more videos dealing with just electronics in general, old and new. So electronic teardowns, restorations, repairs, troubleshooting videos, circuitry design videos, all of that great stuff on this channel. So again, if you haven't subscribed, you're definitely going to want to do that so you get notified when I post a brand new video. If you're interested in taking your electronics knowledge to the next level and learning electronics in a very different and a very effective way and gaining access to many of my personal electronic designs and inventions, you're definitely going to want to check out my ongoing electronics course on Patreon. I'll put the link just below the video's description under the Show More tab, and I'll pin the link at the top of the comments section. So if you click on that link, it'll take you right there. All right, until next time, take care. Bye for now.